Yeah, my name is Michael. I come from Denmark, and I'm a designer for audio products. And for 16 years I've been designing and developing all the Raidho speakers. And parallel to that, because I'm an engineer and I have also been working in the fields of electronics for other companies, we have over a long period of time been developing amplifiers and cables as well. So right now I am the mind and philosophy behind 4 brands, which is Raidho speakers, the Scansonic speakers, which are here in the background as well, and the Aavik amplifiers that are on the rack, and the cables that connects everything and makes it play music. Raidho speakers is developed around the ribbon tweeter, which is in here, and the ribbon tweeter is the best drive unit we have, and we use it throughout the full line of Raidho speakers. We use the same tweeter. It was a tweeter that started the Raidho company 16 years ago, and the philosophy behind that is that if you can take away the moving mass of a driver, you don't have any mass to store resonances in. It will be resonance free. But traditional ribbon tweeters have a big problem in terms of where you need the most power in the tweeter is where you cross over to a dynamic driver. And when you have a traditional ribbon that's open in the sides and just hanging by the ends, then you have the problem that when it goes down in the lower working range, the pressure on the front starts to migrate to the back, and because of that it becomes very weak in presentation. And it's weak where you want to cross over to a dynamic driver that actually starts to beaming and push more energy forward because of geometry and because of the length of the waves, sound waves, and that's very difficult. But in the Raidho company, we managed to make a ribbon tweeter that is actually sealed around the edges, so no pressure from the front can migrate to the back, and that gives it a lot more substance in the lower working range, making it possible to mate it to a dynamic driver. And then ever since, the job has been or tried to do to make a dynamic driver that is as good as the ribbon. I'm not sure that we can ever get there, but every time we improve the driver, the mating between the ribbon and the dynamic driver becomes better and better. This driver is the T driver. This is an X2T, this speaker, and it is a ceramic membrane that is coated with a layer of titanium nitride, which is very, very hard, much harder than and very dense in the surface, and then the pure layer of titanium on top. And that sandwich type of membrane, where you have actually different compounds with different speeds of propagation speed of sound through them, make a very, very stiff but very well damped cone, which is essential to take the noise out of the cone. And the more noise you can take out, the less imprint it has, and the closer it matches the performance of the ribbon. So compared to a traditional ceramic driver, this has less noise, and because it has less noise, the resulting speaker becomes clearer and bigger in its presentation. When we did the Scansonic, the MBs here, we have 2.5 and MB1s here, we wanted to take on the philosophy of Raidho. So I made a ribbon tweeter where the membrane is a little bit different than this one. This one is a polyester foil or PET foil with aluminium. This is a Captain foil, and Captain cannot be manufactured quite as thin as the polyester, but it's much more resilient. So we have a very, very powerful tweeter here that can handle a lot of power, and like this one is sealed around the edges, so they share the philosophy. But this execution of this is a bit more polished, a bit more refined, a bit more optimized, but also a lot more expensive to manufacture than this one. So you get a lot of the qualities here at a fraction of the cost. And here we work with stiff and hard membranes and we work with sandwich membranes from aluminium, ceramic, titanium. Here we work also with a stiff cone, but also a very well damped cone because it comes from a matrix system with carbon fiber and resin. And the geometry here is also made so that by geometry it becomes very stiff. So you can say the two things share a lot of the philosophy in terms of drivers, and also of course in terms of configuration. The system we're playing here today is a Class AB. It's a new Aavik power amp and a new Aavik preamp. And the power amp, it is a Class AB, but it's actually not switching. So in essence of that, it always runs with more current through the output stage than what the speaker draws. And in that sense, you could say it's always stays in Class A because none of the output devices ever switch. And for me, that's the purest type of amplifier you can get. For high power in a small package, like we have in the U300, we have 300 watt in a small package. That is not possible with this technology. And their Class D is a better option to make compact integrated amplifiers. And you can say that when Class D came out, the only benefit of that was high efficiency, because they sounded terrible and they got a very bad reputation at the time. That was because the components available for the Class D was not as developed as they are today. Class D and power electronics for motor drives for cars or for trains or inverters for windmill, they share a lot of technology. And because for those things efficiency matters so much, every time you can just get 1% or 2% more efficient with a better chipset, there's a lot of money involved. So there's a lot of research going on in components for Class D. And every year, every second year, you get a new chipset for Class D where the input capacitance of the MOSFETs is getting lower and lower and lower. And because of that, you have to throw less and less charge to the switching MOSFETs, allowing for faster switching. And the U300 switches at 700 kilohertz. And because it switches with so high, the residuals of switching are barely visible, and the output filtering is very gentle. It's not, by technology, Class D is not as pure as the non-switching Class AB, but performance is very good. Yeah, the X cable, the entry-level cables is manufactured around low inductance, very high mechanical stability, and very high transmission speed, and that gives it a very, very good cable, and that is a basic philosophy we take out throughout the Ansuz range, targeting ever lower and lower inductance. And when we have it here, we do it by bundling the path going to and from very closely, and because of that it tends to cancel the inductance because the conductors are very close to each other. In the higher range, we wrap them in clockwise and counterclockwise spirals, and because of that, and still being very close together, they tend to cancel all inductance. So when you go to the DTC, that inductance is only 1/3 of what you see in the X. So from low to extremely low. You're very welcome. When you have a very, very low noise floor on the speaker, they can go out further. So we take advantage of that to create a bigger picture by having lower noise, so we can actually move the speakers further out. And that creates more depth and more height in the image. I think normally when you have a dome tweeter, it has a lot of noise, and every time there's a transient, automatically you focus on the speaker. But when you have a lower noise floor like we do in our speakers than most, then you have that option of moving the speakers out, and I think it's a great advantage to get them out.